Today we're going to be recreating the Super Mario Bros. 2D platformer camera inside of Roblox Studio. However, first we need to understand how the camera works in order to replicate it. So without further ado, let's get right into it. Now to start off the tutorial, let's go right up here to this view tab right over here on the top, and we want to make sure that both the Explorer and Properties windows are both open. Once you click on these two buttons in the top left, you should see them open up either over here on the right, or they'll be on the left or somewhere along your screen. Now if you do not like the placement of them, you can easily just drag along the top of the window and you can reposition it to any of the other positions that you would like to. From there, let's go right over here to the Starter Players folder inside of the Explorer, and we want to open this up and then click on the Starter Player Scripts button right here. From there, let's click on the plus icon and insert a local script. Now inside of this local script, our main goal is going to be understanding the camera inside of Roblox Studio. And from there, we're going to go ahead and create our 2D platformer camera. And the easiest way to explain it would be that the camera object, it defines the view of the 3D world that you see inside of your game. Now inside of your game, whenever you actually go ahead and play it, each different player is going to have its own camera object that's going to be inside of the client's workspace inside of the Explorer. And you can see right here how we have the camera inside of the workspace, and when I move around with my player, you can see that the camera's orientation and position are going to change inside of the C-frame property. And since this is a local camera or a client camera, that is going to be the same for every single player inside of the game. So each player will have their own control over their very own camera. Now I know what the camera is and what the camera does. I think it's proper that we learn a few basic properties that we're going to be using quite a bit with the camera. So first off, let's go ahead and define the camera inside of a local variable at the top of our script right here. So we're going to say local current camera will be equal to game.workspace.currentCamera. We use workspace.currentCamera right here to go ahead and define the camera that we're going to be using for our player inside of the game, especially inside of a local script, which will get the camera for our local player. And the first I want to explain will be the current camera.camera subject. Now the camera subject is going to be the humanoid or base part that the current camera is going to be following. For instance, if you look at my camera inside of the workspace in the Explorer, you will see that the camera subject is set to humanoid. Now that's a little hard to tell which humanoid it is, so I'm going to change the name of my humanoid to Rusty Silly Band's humanoid, just like so. Now if I go back to the camera and to the camera subject, you will see that the camera subject is Rusty Silly Band's humanoid. Now say there were another humanoid in the game, such as this rig right here, I can easily go up to my rig right here and then change the camera subject of my camera to the humanoid inside of the rig, and you will see that now the camera is going to be following said rig. That is because the camera subject is no longer subjected to my humanoid and is now subjected to this rig's humanoid, which means it is become the subject of the camera. So we can easily set the current camera.camera subject equal to game.workspace.rig.humanoid. That is, if you have a rig inside of your workspace. However, we won't be using the camera subject property at all inside of the script that we'll be using later on. So let's go ahead and delete this line for now. From here, we want to say current camera.camera type. Now, camera type is going to be read by the Experience's camera scripts to determine how the camera should update each frame. Now, I'm not going to go into each and individual camera type. However, the main two that you're going to be using are enum.cameratype.scriptable, which will allow the camera to be actually scriptable and its properties to be changed within a script, and then enum.cameratype.custom, which is the default camera type for a Roblox camera. If you set it to custom, it will be just its classic camera. You can move it around just as you normally would. However, if you change it to scriptable, it'll simply make it so that you can actually script the camera. And from there, you want to say current camera dot C-frame. This is another common property that you're going to be using inside of your scripting with cameras. And there are a few different things we can do with the C-frame, because as you'll notice, the camera C-frame has two different properties within it. As the position subproperty and then the orientation subproperty, which means that if we want to change the position, we can set the current camera.cframe equal to cframe.new and provide a position for our new C-frame property. So let's say we wanted this to be 10 on the x-axis, 10 on the y-axis, and 10 on the z-axis, and this will change the position of our camera to the position of 10 by 10 by 10 on all different axes. Now, if we wanted to test this inside of the game, we're going to have to wait for our character to join the game first, because if you did not know, the player joins into the game first before the character, because those are two separate entities of the player inside of Roblox. So since our script is inside of the starter player scripts and not starter character scripts, we're going to have to wait until the character joins the game in order to run our script. So we're going to say repeat wait until game.players.localplayer.character. Now if we were to play the game, you'll notice that my camera will be offsetted 10 studs in each different direction. And that will be why I am now looking over here instead of it following my character. Now you can also change the rotation or orientation of the C-frame inside of the camera. And we can do that by multiplying our current C-frame by cframe.angles, and cframe.angles is going to use something we call radians. So in order to use radians, we have to convert a specific number or a certain amount of degrees to radians. So we would say math.rad or rad, which will return a certain angle into radians. So for instance, if we want to change the camera 90 degrees, we would say 90 inside of our math.rad parentheses, and we can put a comma after it and go on to the next number. Now, if you aren't going to be changing any other angle, you don't have to use the math.rad function. You can just simply put a 0 and then another 0 for the last number. However, if you are going to be changing the angle, you will need to set a specified math.rad function. Now let's go ahead and press play, and you'll notice that our camera will be rotated in a completely different direction. From there on, we can change the current camera field of view, and I don't think I really need to explain this one so much, because if any of you guys have ever played Minecraft and messed around with the field of view settings, you know exactly what I am talking about. This is the difference between Quaker Pro and not Quaker Pro. Basically, the higher number you set for the field of view, the more you'll be able to see. However, the lower you set, the less you're going to be able to see. This is typically used to give the illusion that the player is moving faster, as you can see from this field of view property that I just changed up to 120. Likewise, it can also be used to make the character seem slower if you were to set it to a lower number. From then on, the last property I would like to go over is the focus property. Now, the focus property represents the point that the camera is looking at. Now, typically, if you have your camera subject set to the player's humanoid, the camera focus is typically going to be at the humanoid's position, or the humanoid root part's position, which is the base part that will represent the main root of the character. Now, that's just about all that you need to learn about the camera for now. We aren't going to need this script anymore right here. So instead, let's just start right up here at the top. We're going to say local players will be equal to game::get_service_players. This player service that we're referencing inside of this local variable is going to be this player service that you will see inside of the Explorer. From there, let's drop down a line. We're going to say local run service will be equal to game::get_service_run_service. Run service, you won't actually see it inside the Explorer, and that is because it is a built-in scripting service, and it's typically used for time management related scripting inside of Roblox Studio, and we'll be getting more into that later. From then on, let's go ahead and get the local player. So the local player will be equal to players.localPlayer. From there, we also want to go ahead and get the local current camera that we were getting earlier when I was explaining what the current camera actually is to you guys. And so the current camera will be equal to game.workspace.current camera. And now it's probably best that we set some different types of settings for our camera. So for instance, we're going to want to get the camera Y. And this, we're going to start off setting to 10, just to get a bit of a reference of to where we're going. We can always change this later, so we're just going to start with the base number and then change it if we need to. From there, we also want to say local camera Z. And we're also going to set this to 10 for now, which can also be changed later. So the Y is going to be how high the camera is going to be, and the Z is going to be how far away from the player we want the camera to be. So if we want it to be close, we're going to set it to a smaller number. If we want it to be farther away, we're going to set it to a larger number. From there, we want to set a local camera, and this will be the local camera X. And we also want to specify this is going to be the local camera X movement, because if you look at the original Super Mario Bros. Game that we were modeling this afterwards, the camera doesn't follow along immediately with the player. You'll see the player is able to move a little bit and then the camera starts following them afterwards. And since we want to replicate that, we want to have a little bit of wiggle room that the player can move before the camera starts chasing them. So we want to say the local camera X movement will be equal to 10 for now as well, which we can always change. We also want to specify a variable for the camera speed, which let's set down to 0.2 for now. Actually, I'm going to say 0.3 just to make sure. And this is going to be the rate at which the camera moves or chases after the player. We don't want this to be too fast or it'll be too jarring. We don't want this to be too slow where the player will be able to get ahead of the camera. From then on, let's go ahead and say player.character added, which means that their character finally got added into the workspace. We're going to go ahead and connect a function right here, and we don't actually need to specify the character as a parameter, but it is good practice to do so. From there, we're going to say camera, or our current camera, I mean to say, dot camera type, which is going to be equal to enum.cameratype.scriptable, because we're going to need to be able to script our camera to chase after the player. Next, let's go ahead and drop down the line. We're going to say current camera.cframe, just like we did before, except this is going to be equal to cframe.new. We're going to say 0 on the x-axis. For our y, we're going to put our camera y variable, and then for our z, we're going to put our camera z variable. Now at this moment, if you were to press play, you will notice that our camera will be facing off in this direction, which is exactly what we would like for our platformer. We can press stop now and go back to our local script. And that is all we need to do inside of our player.characterAdded function. Now let's drop down a few more lines right here. We're going to create a brand new local function. And this we're going to call update camera, just like this with parentheses, and we don't need to specify any parameters for this function. From there, we can go ahead and get the character inside of a local variable, and this is going to be equal to player.character. And since this function is going to be after the player.characterAdded function, we don't actually need to worry about adding in that or player.characterAdded:"wait" nonsense. From there, we're going to check if the character exists, and character:"find first child humanoid root part." Then we're going to put the humanoid root part inside of a variable. So we're going to say local humanoid root part is going to be equal to character find first child humanoid root part, just like so. And then local player x is going to be equal to the humanoid root part dot position dot x, which is going to get the x-axis position of the player. This is important because later we're going to be using the camera X and the player X position to specify whether or not the camera is going to be able to chase the player or not. Speaking of the camera X, let's go ahead and say local camera X is going to be equal to camera or current camera dot cframe dot position dot x. This is going to get the current camera's X position, and then we're going to use a math function inside of Roblox that you may or may not have heard just yet. And this one is going to be if math.abs, and no, this does not mean that you'll get those hard Roblox abs by using this function. It means that we're going to get an absolute value from whatever we put inside these parentheses. So if math.abs is going to return an absolute value, camera X minus player X is greater than the camera X movement, then. Now, if you're wondering what I meant by an absolute value right here, which means that it's pretty much just going to take whatever this number is and then convert it to a positive number if it is a negative number. We can see this because if we go up here and print math.abs -1 and then press play so that this function runs, let's go ahead and press this button to open up the output. And you'll see that 1 will be printed inside the output, even though we put a -1 inside of the parentheses. We can stop the game now and go back to our local script, and we can get rid of this print statement. So if the camera X position minus the player X position, which will leave us with the number differing the two, and if that is greater than the camera X movement variable, which is 10, then we're going to go ahead and start chasing the player. So we're going to say local direction will be equal to parentheses player X minus camera X, not camera Z, camera X is greater than 0 and 1 or -1. Let's break this down a little bit more because this is a little bit complicated. If the player X minus the camera X is positive, it means the player is to the right of the camera. However, if the player X minus the camera X is negative, it means the player is to the left of the camera. And that's going to check if this condition right here, if player X minus camera X is greater than 0, if that is true, meaning the player is to the right of the camera, then this part of the expression is going to return 1, representing movement to the right. Or -1, which is going to do the same thing, but it's going to represent movement to the left instead, which sounded really complicated, so I'm going to try and explain that a little simpler here. If the player is to the right of the camera, this is going to return 1, telling the camera to move right. However, if the player is to the left of the camera, it's going to return -1, which will turn the camera to the left. An easier way of writing this out just for an example, let me just turn this into a comment right here. We could say local direction up here as a empty variable, and then check if the player X minus the camera X is greater than 0, then we're going to say direction will be equal to 1, else the direction will be equal to -1. However, the original version right here is simply a more concise way of writing this logic. So we can get rid of this right here, and then we can untoggle comment this line of code right here. And now we can move on with our script. So we're going to drop down a line real quick, and we're going to say current camera dot cframe is going to be times equals cframe dot new camera speed for the x-axis times the direction variable that we just created. And then we're going to put 0 and 0 on the y and z axes because we already have those set up here. So we don't need to change those at all. So the camera speed times direction. Oop, I messed that up. Camera speed times direction, as I was saying, this determines how much the camera should move on the x-axis. The camera speed is how fast the camera should move, and then the direction is either 1, move right, or -1, move left, depending on the player's position, which is relative to the camera. That's all we need to do for our update camera script. So let's go down a little bit more, and now we need to actually call this function whenever we need to update the camera. And this is where that run service variable that we got earlier up here at the top is going to come into play. We're going to say run service :bind to render step. And now we need to give a string right here, which will be camera. And then we need to specify a priority property, which is going to be enum.renderPriority.camera.value. Then all we need to do is call our update camera function to the right of the enum priority. And just like that, our script should be good to go. So all in all, this script is simply going to create a basic camera system where the camera is going to follow the player along the x-axis, ultimately keeping a very specific distance between the player and the camera. And then we're simply going to update the camera's position smoothly based on the player's position. Now, that was a lot to take in, but we sure learned a lot, and now we get to do the fun part. Scripting was just the fun part, but this is the really fun part where we get to test it. So let's press this big blue play button right up here, and we can join into a game. So now whenever we join into the game, you'll see that our camera is facing forwards just like this. And if we move to the right enough, you'll see that the camera will start following our player. And if we move to the left enough, the camera will start following our player as well. However, in this little in-between zone, we have a lot of wiggle room, just like in the Super Mario Bros. Game. Now, of course, we can still move forward and backwards in all different directions. We'll take care of that in the next episode. However, for now, this is going to be our basic camera system for our 2D platformer game inside of Roblox Studio. Thank you so much for watching. If you enjoyed this tutorial just as much as I did and learned from it, please make sure you like, subscribe, and comment down below, and I will see you in the next episode. I'll see you guys later, and I hope you have an absolutely fantastic rest of your day. Bye.